So can someone fix the data property so we can work that again? It's just not this one. Still in the process of it has been for 10 minutes. And yes, that's the slides, the old version of the slides. Oh, it managed to do it. You know, to do it. So we load that. You load. Maybe you can. So just to show you how it usually looks like in the last 10 minutes. That was good, yes. Okay, so we have managed to upload the slides, which means we can start the meeting, and we should. Oh, there's actually some feedback going on. Okay, so this is the second meeting of the core working group, and note well and everything. Please read RFC 8179 and this slide. This is the agenda we discussed on Monday, and we actually managed to move some of the items around. So we will take up the parts of OSCORE we didn't manage to do on Monday first. Then we go through a number of active drafts, like CNML fetch and PubSub and so on. And the last 25 minutes are for discussing congestion control, and in particular the new submission called Phaser that we didn't get to in Montreal, unfortunately. And if we have a little bit time left at the end, then I have another draft to just point to. Anything else missing on this agenda? Anything we should change? Peter, what's missing? You sounded like, you looked like that something was missing. This is okay, good. Oscar.
Hello, everybody. I'm Göran Selander. I'm going to present the update on OSCORE. So the status is that we are in version 15. That was submitted in August. And there's one discuss left from Hacker. And we got a few comments from him, channeled through Alexei this Sunday. So that's what we've been working on now. Unfortunately, it got congested in AD space on the way. But anyway, we've started in this meeting to work on the comments. Basically, there are three high-level comments all related to the unprotected message fields. So as you remember, we introduced an Appendix D to handle one of Ecker's previous comments. And in particular, D4 is looking at, if you like, a residual risk type of scenario where you have protected the message and you still have unprotected message fields, and what's the consequence of that? So for example, outer code can be changed. So, which actually is not a problem, because outer code is a dummy code, and the inner code contains the the actual method that is end-to-end encrypted and integrity protected. And then, so that's probably a misunderstanding. Then we have a comment related to proxy operations, that proxies are allowed to change things like options. It could change URI host, URI port, and scheme, and so on. And that was the question why that is okay. And that's essentially what co-op forward proxies are allowed to do. So that's, I think that should be quite easy to answer as well. And the third comment related to messaging layer. So as you know, OSCORE is not protecting messaging layer. It's only protecting the request response layer and the REST operations. And that's because we want application layer security that could work on other transport. So co-op over TCP doesn't have a messaging layer, so that's not protected by OSCORE. And then we can protect co-op over TCP using OSCORE. And again, that's also, I think, related to the understanding of exactly what are we protecting with OSCORE. So we had a meeting with Ecker on Monday to discuss this, and he's missing a threat model, basically framing that part, sort of what do we protect. So that's the proposal for resolving these comments. Is basically we make a few minor clarifications on these points, and we add this Appendix D, which is a threat model. And we plan to do that based on, or actually, we've done that based on RFC, which is looking at threat modeling. So those were the three comments. And then was a fourth comment, which related to, which was actually a comment from Bhargavan, Bhargavan, relayed via Ecker and Alexei and arrived on Sunday, which was about storage to non-volatile memory. That was a good comment, we think. So we have this on a separate slide. So this relates to how we handle loss of mutable security context. And this is not mandated in OSCORE, but in section 7.5, we give examples of how you could use non-volatile memory. In particular, writing sequence numbers to non-volatile memory. And there's a simple write scheme. It's basically saying that if the sequence numbers are divisible by k, then you write it to non-volatile memory. Then you do the operation. And if you happen to reboot, then you read from non-volatile memory and you add the interval k. Now the issue here is that writing to non-volatile memory may have an unpredictable completion time, which means that you might not have you might have lost this write operation due to reboot. And the proposal is also indicated by Ecker is that you look at other ways for handling loss of security context. And there are various ways to do it. So the proposal is that we expand on the alternatives. One alternative is obviously to make a key exchange protocol, which would have a large overhead and require good random number generation. Another example is that you involve in a trusted third party assisted key provisioning, like one of the ACE profiles. And there is also a third variant where you still have the shared key available, although the context is not up to date. So you could use the shared key and you could introduce a random number and derive a new context. All these are perfectly fine examples. So we've added those, and we also like to keep the case of storing to non-volatile memory, but we will emphasize the issues and update the write scheme so that we, in addition to adding k, we also add some upper bound for completing the write. So that means additional safeguard against reuse of sequence numbers. But we like to allow the application to decide, because in some devices, handling the write to non-volatile might actually be more secure than relying on bad random number generator. So that's the proposal here. Any comments on that?
So just to clarify, this is not a change to the protocol or anything. It's an addition to the security consideration that an implementer should be keeping in mind. I mean, we knew all this, but writing it up for people who don't know this is very useful.
Yes. I mean, these are all these are examples, and the application has to decide. And exactly how you set up, as you know, OS Core assumes to have secure keys in place, and how you get those keys in place is sort of delegated to other protocols, like the ACE profile of OS Core, or like ad hoc, or like some other mechanism. Okay, so that's it from the in terms of comments. We have made these updates as proposed here. Please look at them on the GitHub. And we see if there are any further comments right now, then we will make an update, and then we wait for further comments from Ecker. We plan to have another meeting with Ecker this week, see if we can fit that in.
Yeah, from a sharing or document shepherding perspective, the problem really is that we are giving a little bit of view that this document is unstable because we are generating so many new versions. But the reason is that we get the comments in piecemeal fashion, and we are trying to react to each of these. And yeah, that doesn't really look very good. It requires some explanation to people who are looking at this process and asking, why do we need 10 revisions to get this through the ISG?
Okay.
Hi, Padma Kumar from Nokia. My question is, as a chair of DMSE working group from OMA, we have quoted this for 1.1 specification, and we have approved that lightweight M2M 1.1. I hope this gets completed and moves to the next stage as fast as possible, because I thought this would have been done sometime back, but we're still expecting.
We thought it would be done in March.
Okay, so next draft, or any more comments?
You have about minus 20 seconds to do the other ones.
Thank you.
But maybe use those.
I try to use them well. So echo request tag is in version 3. We have updated according to all review comments. We got really good comments from Jim. So we think this is ready for working group last call, and I think Jim actually agreed on that. So there is a normative dependency from process stated to request tag, which is yet another reason why this should progress. You want to take that separately, or should I go on to actuators? I'm done with request tag.
The usual quick questions. Who has read a recent version of echo request tag? 1, 2, 3, 4. So this is going into working group last call now. So please have a look at it and find out whether there's something in there that is horribly broken before we issue the working group last call. So this is the time to actually look at it.
Okay, and this is really quick. That's just explanation what this draft is. So echo and request tag were two separate drafts, having separate problem description and solutions. We took the solutions and put in the draft we talked about recently, and this draft is about the problem statements. And the question is, what does the working group want us to do with it? So it's an informational draft. Should we complete the problem statements? In that case, I think that's a really good time to do now, when we are moving to working group last call for the solutions, or should we drop it? Sorry.
Yeah, Carsten Bauer from the floor, chair head off. This is essential. I mean, what remains is essentially advice for implementers. There is a problem here, and make sure that you do the right thing. And we have a working group that collects advice for implementers, and we actually have a document called LW CoAP that has advice specifically for CoAP implementers. So that would be one potential way to get this into publication.
So to contribute to that document, or to submit to a separate working group?
Well, we would just copy the text of this document into LW CoAP
Okay.
And that would be one way of making this information available.
Fine.
So another way, if we think some of this information is really important enough to consider to be a correction or clarification, we might push it over into that document. So I think that's a good question we should ponder and then make a decision in the next couple of weeks how we do this.
Okay, thank you.
Thank you. Can you give me the controller? So we now have the gong show of active drafts. We're going to go through half a dozen active drafts quickly. Hop limit, that's something that we owe to the DOTS people. We promised we would solve that problem for them. And there is a working group document that has been around for a couple of weeks. That was discussed at interim meetings, and apparently we have been pretty slow to relay our concerns to the authors. So right now there is still some clarifying going on whether the concerns are actually addressed in the current document or we need a -01 before we can go for working last call. So just to remind people, this gives us a way to limit the number of hops, the number of proxy hops a request takes from the client to the origin server. Fetch and patch with Senel, Ari.
Okay, thank you. So this is was recently adopted as a working group document, so we're now at version 0.0. Here's what happened on updates since the 0.3. The key thing was we clarified the security considerations section that even though you are able to address multiple names in a single patch, you are not conceptually reaching to different resources. That was the impression given in the earlier version. That was a small change we did there, but the bigger question is, do we want to do new media types or not? So as Christian pointed out in his review, there are some challenges with the way reusing the existing Sentinel media type, even though the current way of reusing that maps nicely with a couple of different operations using the same Sentinel constructs. However, if you do patch or if you do fetch, there are issues that Sentinel RFC said you must have a V value in all of those records. And what we were proposing for the fetch method was that you simply give the names. So we had a conflict on how you're using the Sentinel current media type. So after some discussions on the list and also with the OMA-DM, it seems to be appropriate that we actually do have different media type for fetch and patch. So then we don't have these issues of being fully aligned with the existing Sentinel RFC. We are still using the same constructions. It's just that we don't have this issue with having, for example, something different for the V value that would expect otherwise. So the proposal here is that we would go back to new media types, and key questions, if we go that way, do we have the same media type for both fetch and patch, or do we require two media types for that? And then also, is it JSON or do we also do CBOR? So having at least the JSON and CBOR seems to be a reasonable way. Probably don't want to have XML and EXI ways of doing fetch and patch. So any questions or comments on this one?
Hi, Padma Kumar from Nokia. So I believe the same media type would have a clash, right? And you obviously need to go for a new media type.
Yeah, the same media type, technically you could define different semantics for a different method, but it was a bit stretching it. So having a separate media type seems to be a more clean solution.
And the other reason why new media type may be more correct is that there are patch documents that are not valid CNMA documents.
Yes, so if it was the same media type, then you would need to know basically also the method that it was used in order to be able to interpret later on. So if it's a separate media type, those issues go away. The good thing, of course, would have been that we could be able to use all existing media types as such. Now we have to register, depending how many we end up with, 2 or 4.
Alexander, so +1 for the different media types, and also about the question of trying to support many different serialization formats. I would say stick to the minimum thing that works, and then extend in the future if someone wants that. So CBOR looks really a great way to encode the data from. Everything else is like optional. Sorry? A new binary format? And then okay, no, yeah, that will be later.
Hi, Padma Kumar from Nokia again. I think earlier suit as well, I heard the same kind of discussion, but I want to make it here with the CBOR. So whatever we are doing in terms of in IETF, we are looking at things what is needed for next +2 years, +3 years. So if we are going on extending and supporting legacy formats, content types, or whatever it may be, I think that's not the right way to go. So in this case, CBOR is the way to go for sure. And we should not look at things from backward. Similarly, even for the suit, I had the same comment that don't look for legacy stuff. Look for what is going to be produced in the next 2 years, which may not even be the same board as we are looking at today, what Hannes is carrying around. So.
Okay, so I'm hearing that CBOR makes a lot of sense here. Good. So, but I guess we could also still keep the JSON one, just not do the XML and EXI. Those we can leave for just plain XML.
This actually, I'd agree that you should keep JSON. I'm going to see this used in other places in the infrastructure, more backend, to move information around that's been done with CNML. So I think it's worth keeping both. But I'd agree that EXI not really necessary for this.
And how about the same media type for fetch and batch? Is there a reason to have separate for those, or can we just have a single one that is for both fetch and batch? We almost have the same for all of them, so having a single one for fetch and batch seems reasonable, unless there's something we're missing here. So I see people nodding that one media type for both is good. Okay. Then the other issue, now when we have the new media type, how do we do deletion? So all the other operations are quite straightforward, except how you indicate that you want to delete a record from a patch. And at least these 3 different ways are options for us. The first one is what is currently in the draft. So you would indicate that value is null. That's the JSON merge patch style of deleting things from JSON construct. It is kind of clean. There is an issue that instead of RFC said that, okay, you should own. Well, instead of RFC, that we had different tags for different kind of values, and now you would have a V used to have only float. Now we could also have a null. It's a different media type, so it's not that big an issue that some parsers could be confused. An alternative that Christian was proposing in his review was this VDEL equals true or something similar, basically a flag in the record that, hey, now I'm indicating a record with a name and I want it to be deleted. The good thing about this is that it doesn't have the problems of the variable types. On the other hand, this would require a new tag. It's not a big cost, and it's slightly more verbose in JSON because you actually write the true with 4 letters. In CBOR, of course, it becomes pretty compact. And the final option is to have this JSON patch style operations. So you have define a new operation that says remove.
If you want to save bytes in JSON, call the thing X. As an X out.
That's my reaction is like flip a coin. Yeah, I mean, I think op remove is sort of more readable for people who are not necessarily versed in this, but I think any of this is fine. As you said, you're already defining your media type. So we now, it's sort of a bit hackish, but it sort of works.
Alexander. So the thing is, I have not really thought about how this fits in SNML. So probably some of the things that I might say, they will not make sense to you, but I look this through the point of view of COMI, because there we did a lot of things in fetch and patch. And I mean, we consider this from the start. And then there we did it with the null. So, but it made sense, right? I mean, by looking at the schema, I think it was really clear that you knew that whenever you got null, then you know that like the operation was removal of the element. I have not thought about like the variable things. So that could be a question here, right? But maybe one thing to look at is as COMI does the patch and fetch, and there one of the points over there is that we also said that okay, we need to have two media types, just so that we differentiate between fetch and patch, because the structure is a little bit different of the payload that goes there, because the operations there are a little bit different. But then, I mean, as I said, I have not really, I mean, probably you have much more feedback on that point. So if you don't risk your code, just by some chance you get your fetch method or some payload gets redirected to the patch, and then some strange stuff happening, if you have a different media type, then at least you're sure that's not going to happen. The thing is just going to say, well, I don't know how to handle that thing.
So did you discover in the COMI work some cases where you would have this confusion that you would actually have to know from the media type whether it's fetching or patching? Are those documented somewhere? Would be good to have a look.
Well, actually, we had big discussions at the time. We were like, okay, do we go with everything is just CBOR encoded stuff, and then we look at the method, is it fetch, patch, get, put, post, delete, and then based on that, we can infer how the CBOR is structured. So that was like the one end of the spectrum, and the other end of the spectrum was, okay, we have a media type for every type of payload, and because there were several things that we can encode. We can encode individual elements, we can encode collections of things, we can encode fetch, collection, how do we perform the fetching of things, how do we do the patching of things, and actually it was much more readable with having several media types, because, I mean, at least in the COMI, otherwise it was like, okay, well, in this case I can have like a list, then if it's a list, then this means that. If it's an object, then it means that. So it actually started getting really difficult to read the standard, the draft. So there it made quite a lot of sense to do this. So just like a feedback on that.
Thank you. So yeah, we'll have a look at that background. So, but it seems all of these options are no one has like a strong know on any of these. So we'll have a closer look, but maybe following the COMI approach, vnull could be a sensible one. Good. That was all. So the plan is now to submit a new version addressing these comments and hope to get this into an RFC soon, because again, live with M spec is pending on this and would need to get this out. On the timeline, when do we think this could be going for last calls, if we now address these comments?
Is there anything resembling an implementation of this?
Well, there's going to be Plugfest on Live with M2M early next year, so there is going to be implementations of that tested. So
I mean, this probably can be implemented in approximately 2 hours. So maybe somebody should put in these 2 hours. Just to get some feedback whether there's some snags somewhere.
Yep, that is true. So yeah, so let's say request for all of you have a SNML implementation. Please spend the 2 hours on this and let us know.
And yeah, send to the mailing list so we can agree that this is cooked and we can go to working class core. Thank you.
Thank you.
Michael. You're on.
Okay, can you hear me? You should be able to. Yeah. Okay, great. Well, whatever order you want. Okay, core. Yeah. So basically, status is there haven't been a lot of changes, but we got some good feedback. And basically, what we need to do is rework the examples to conform to the current practice for CNML and link format. I think there are some fairly minor changes to make there, but sort of comprehensive throughout all the examples, and just to make sure that we're up to current practice. And we can probably do the review of that in an interim meeting if we continue with the schedule on interim meetings. And I'll spend some time on doing the update as well as Bill. So I think we'll be able to get into the review cycle again after in the interim before the next meeting. I think that's all I have on this one.
Okay, so next, DynLink.
Yeah, DynLink. Basically, recently I've done a reference implementation of the conditional observe attributes in C, and also there was some learning, interesting learning about that. And it turns out that there's really a simplified logic expression. And also there's some learning from developing the OCF version of DynLink. And with OCF, we're not using the conditional observe, we're just using the DynLink pattern itself. So I've got a couple of slides just to sort of some examples. The next one, please. What is the next one? Oh, okay. So basically, this is the C code that's just 2 pages. The second page, next, yeah, okay. And then there's some definitions, and then a couple of logic expressions that cover scalars, strings, and booleans. Take a look at that. That's referenced in the GitHub, and it's actually in the current draft now as well. Let's see, next slide, please. Yeah, okay. Well, basically, we're going to add a state diagram to make it a little more clear along with the code. There's some good feedback that we got, and essentially what we're looking at doing is Christian Amses gave us some feedback that we looked at, and I think we want to basically do that and provide these observe attributes in the example document as query parameters to the observe request. And there are some questions and issues about that, but on looking at all the options, that seems to make the most sense. And doing that, we could restructure the draft where we introduce the observe attributes and then talk about DynLinks, and then we have this binding table implementation. So I've also agreed to take the action of restructuring the draft, just simplifying it, streamlining it this way. And also that there are some comments that we want to address. We want to add some implementation notes about how the link state tracking works, which I'm doing as well in the OCF version. And I think we note that the implementation might just reuse the observers that COAP has and use updates. That seems to make sense as well. So we're looking at sort of putting in those notes and completing that sometime in the interim before the next cycle as well. Okay, next slide, please. Okay. I guess I'll take any comments and questions after the whole. And so PubSub, not a whole lot of changes recently, but we've got some good feedback from Peter Stock, I believe. And we want to track what's going on with the 429, although I think that things are looking fine for that. They're no big deal. We wanted to get some implementation experience with PubSub as well, and we want to maybe set up an interim, a mini plug fest. And I've been talking with Federico at FINEROP on the sort of VPN modes we might need to do that. And so I don't know quickly that can happen, but I think that's an approach to getting some implementation experience, and I'm going to produce some kind of implementation of PubSub, and we'll see how that goes.
Who in this room has an implementation of PubSub? Jim has one. Jaime has an older version. So when do we do this plug test?
I'm not. I guess we have some interim. The next IETF is going to be in March, so I hope we could do it between now and March. But you know,
Jim?
Jim Schott. Well, we can't really do it any faster than when the next version of the draft gets published.
That's right. I don't think though there's going to be any more big changes. So I think what we'll need to do is, you know, roll up the changes that we have. And I think, Jim, we've addressed most of your comments in the current version of the draft already.
Well, I've already actually, no, I've got a Dash 05 review out there.
Ah, okay. You've got it. Well, since the last meeting, huh? Okay. So
the other thing too is just an FYI. Doing interop is a little bit hard for those of us who run on Windows, so that may not necessarily be the best VPN.
Oh, okay. We're sort of looking at some ways of using OpenVPN also, but what we really want to do is make a VLAN and sort of have a standard little router box that people can do. And that's a little ambitious, but it seems like that's really the way to make it work, right? Anyway, separate topic, but maybe we want to try to enable that right away.
Yeah, so we have to figure out those plugfest logistics. I think we can do that on the mailing list, and apparently the most important next step is to get that document. So Michael, if you could press the button at some point.
Okay, good. I have some changes ready to go. Okay, great.
Great. There's one more comment. No comment. Thank you. Thank you, Michael. This is a very short meeting. Sorry for rushing you through this. But we have some more items on the agenda. And the next item we have is congestion control. And while Ilpo is coming to the front, let me just report from a meeting we have had yesterday between the two groups that have congestion control proposals out there. And as I said on the Monday meeting, we have some interesting observations about the COCO document, and we had different understandings. We noticed this in London and ran out of time resolving this in Montreal, and this time we finally nailed it. And while nailing it, the authors of the COCO draft noticed that they also have different understandings of what's in that draft. And that, of course, puts the validity of the simulations and experiments that are referenced by this draft in question. So for us, it's back to the drawing board. And I have asked Mirja, who is the responsible AD on this document, to just push this document back to the working group. And if we manage to fix this, we can do a new working group last call and handle this again. So that's the status of COCO, and now for Fixer.
Yeah, so I'm going to talk about this new congestion control proposal called FASR and Ilpo Järvinen. So FASR tries to balance between there are these two contradictory goals. So in the random loss case, you would want to trigger the RTO very fast because the packets are not lost due to congestion, and then in case of congestion you need to slow down. So there are you need to do both ways, and it's hard to know which way it is. And we realized that in the IoT deep learning, congestion mostly is expected to occur when you have very large number of devices. So we wanted to test such scenarios, and this is the way we came across these problems. And we discovered that both the default COAP and COCOA have some issues that lead to congestion collapse. These were reported in the London, like Carsten said, and they will be fixed for COCOA, hopefully. And Fuzzer is designed such that it is not vulnerable to the same issue. Despite handling the congestion well, it is also able to handle the random loss cases very well. So you don't see the slide titles at all. So what's the problem with the problem with this congestion control proposal? So there's, first of all, there's this CONS algorithm, which is very old thing for TCP. It uses exponential backoff and keeps the backed off RTO until it gets an unambiguous RTD sample. Then on the other hand, we have this COP congestion control algorithms, which they do exponential backoff, and there is this thinking, many people think that this would be enough, but even in the transport people, we have seen that people think that this would be enough, and then the problems show up when the RTO is not retained, like with Kahn's algorithm. And I will not go to the details how this is manifested in default COP and COCOA, but you can read it from here or look back to the slides, and there are some references to this London presentation and one other paper. But on the same time, we learned from this from COCOA and default COP that it is good for the random loss case to actually be able to get the RTO fast. So this is what we try to do in Fuzzer. So we try to find a good middle ground between these two extremes. So we try to improve the random loss, but still handle the congestion cases safely. Fuzzer has two ways to calculate RTO. There's fast RTO, which is basically the same as the normal TCP RTO. There's only minor modification to that. And then we have this new thing called slow RTO, and then back-off logic, which selects which of these RTOs to use. So fast RTO, like I said, is like this TCP RTT computation. We have this small modification to the initialization, which lowers RTO for short exchanges. We have added this K there, so the RTT var becomes smaller. So if you have short exchange, it helps. And then the slow RTO is analogous to this Kahn's algorithm, which keeps the RTO until the unambiguous sample. So we see this. Here is this figure. So we have this original transmission here, and then some RTOs, and finally we get the ACK. So we take a measurement how long it took to actually get the ACK. So in the worst case, this is our RTT, and then we apply some additional multiplier to that to make it even safer. And I will show on the next slide how we use this. So we add additional states. So normal Kahn's algorithm has these two states. So it has the state where it's using normal transmissions, and then the second state which is using the longer RTO. But in Fuzzer we have this intermediate state where we start with fast RTO and only then use the slow RTO, and after that we again can use the fast RTO because we have handled congestion if there was such already quite well. And then the last state starts with slow RTO in order to ensure that we can always take a RTT measurement. And these state transitions are such that always if we get unambiguous, we end up back this fast RTO or this fast state, which is using only fast RTOs. So this is the normal RTO backoff series. The point of all this is to avoid using slow RTO as much as possible, because it has inherent cost if you need to actually wait for that. So if that particular bucket for which you have armed the slow RTO, if you need to wait for that, it takes lots of time. And in random loss cases, it's of course not very nice to wait because the bucket was not lost due to congestion. This is mostly what I already said. So then we have this optional feature. So there is possibility to always get accurate RTT estimates, so that this retransmission ambiguity problem is removed using this option. So option reports which of the actual, so when we send retransmissions, we don't know which of those request copies actually triggered the acknowledgement. So with this, using this option, or alternatively, the option can be, or the ordinal number of the transmission can be encoded to the token too, since it's the client can decide what to put into the token. So it has this possibility. So it doesn't need to always use this option. It doesn't want to. Then I will show some of the results. So we have this low bandwidth, high delay environment, and where these clients perform 50 exchanges per each client, and in order to simulate short-lived clients, we reset the congestion control state after 1 to 10 messages. And for Cocoa, we have disabled aging because we have discovered a problem with it, and it was misapplied to these busy flows. This has been reported in London, so you can probably get more details from that presentation. So we have two test scenarios. So we have this heavy congestion, which includes also buffer float cases. And we have tested up to 400 parallel flows, or well, it's parallel clients. We call a flow one of these client or this set of clients which perform 50 request responses in total. We call it a flow, even though technically it's not a flow. And our largest buffer size is infinite, so that there won't be any congestion losses. It's just a plain buffer float. Also tested some smaller buffers, and with 400 clients and infinite buffer, the base RTT will be like 10 seconds. So if each of the flows or each of the clients have just one bucket in flight, the base RTT will be this large. So, and then there are other cases, this random losses case where there is no congestion and then parallel clients, and the error models are also mentioned there. So it's quite bursty error model. So this is now with 400 clients. So we have the heavy congestion and buffer bloat, and in here this congestion collapse problems is shown with the default co-op and COCO, and because Fazor is able to handle the congestion well, but it gets much better performance. And this problem is mostly due to unnecessary retransmissions. So the Fazor logic is able to reduce the number of unnecessary retransmissions very dramatically, which reduces the RTT, and it then shows in the flow completion time. Did you have some question?
Yeah, Carlos Gomez. One question: which is the network topology you are considering in the evaluation?
Well, we have shared link from this this server. So and the bottleneck buffers are shared between all these.
Okay, so it's just one link, and all the flows go through this same link.
Yeah.
Okay, thank you.
So then the results with random loss. So here again the median for Fazor is significantly smaller than default co-op or COCO. And on the RTO side, it's probably not well visible in this, but if you look on your own screen, but the right-hand side figure. So the initial RTO is 2 seconds, and the base RTT for this case where there is no congestion is this 660 milliseconds, and the Fazor is able to lower this. Even though there are only very few request responses before the congestion control state is reset. So this is very challenging from congestion control point of view, because you all the time keep forgetting your RTT state. So we need to always relearn it very quickly. Here the token variant shows the best performance, because it can immediately always learn this, even when there were some losses due to link errors. And one interesting detail from COCO is also visible here. So the RTOs actually grow, because when there are enough errors or enough random losses, the weak estimator collects this noise from the ambiguous RTT samples. So instead of converging towards the real RTT, it's actually increasing it. And in Fazor, we avoid this because there is this fast RTO is only updated on unambiguous samples. So we never take these ambiguous samples into the fast RTO measurements or the computation. Then we have some items which these might not make sense to you unless you have looked more to the details of the algorithm. So, but I will anyway go through them now. So, occasionally this fast, slow, fast state backup service is such that it may actually be more aggressive than what goes on in the fast state. We have also tested a more conservative version, but it has small measurable impact, but we are not sure whether it's actually useful to add this extra conservativeness to the algorithm, since the slow RTO itself is already quite conservative. Then we have our own dithering algorithm, and it might be useful to consider using the same dithering algorithm as the other congestion control approaches have been using. So then my conclusions. So FASO achieves this balance between handling random losses well and then also handling congestion. And traditionally, it has been thought that handling congestion automatically means that you will lose some performance in random losses case, but FASO logic is such that it is able to mitigate most of this problem, so it doesn't have that high impact. And on this results I showed you, there is this thing that since the algorithms are too aggressive in congestion case, they benefited in the link error case. So if the congestion case will be handled correctly, it likely affects the link errors case or this random loss case performance somewhat. And we think that the FASO algorithm's complexity is not significantly higher. It might even be slightly lower than what's the complexity of COCOA. And because of the promising results, we believe that it would be beneficial for the whole ecosystem. And we don't know if this group maybe has some interest to work on this item. So I leave it as a question for you. Well, I would actually cover the next slide, which I have on the backup slide. So we have tested also with this.
So we are already over our time, and I have an administrative point I have to make. So can you give me? Sorry. Look at the slide and be impressed. This is interesting stuff. This is good stuff. And at some point we will have to decide whether we want to adopt this. One very important question that came up when we looked at this is there is an IPR declaration on this. Generally, this is the second IPR declaration we have had in this working group, and this working group has been around for a while. Generally, we do not discuss any patent claims. This is a patent application at the moment in meetings on mailing lists. But the procedure is that working group members form an opinion about this and decide whether they think this is an obstacle to working group adoption or not. So please read this IPR declaration and see whether that would be an obstacle to adoption from your point of view. And you have to form your own opinion. We cannot have any reasonable discussion about this. Patent law makes that generally impossible. So the one thing that might happen is that the patent claim owner chooses to speed up the discussion by providing more information. Right now, the IPR declaration is very basic, has essentially the information that you have to give, but not much more. But sometimes IPR owners choose to provide more information to make it easier for the working group to understand the impact of this IPR declaration. So right now it's very hard to understand because the actual patent application probably won't be published before January 2020. So right now we are just in the dark. So let's see whether that happens. But independent of that, you can form an opinion on whether this would impede adoption or not. And when we think we are ready for working group adoption, then, what you say about whether to adopt or not will be influenced by the position that you have created on this point. So sorry for this little announcement on how to handle patent claims, but again, we haven't had one in this working group We had one before, which was a 7-year submarine thing. And I'm not going to say anything more about that one. But this time it has been properly declared. Everything is wonderful from a procedural point of view, but we still have to find out how we want to handle this. Thank you. Any more comments on this? So who has ever read any congestion control document that was worked on by this working group? Oh, quite a few. That's good. Okay, so maybe those of you who have done that, please have a look at this and form your opinion on whether this is technically good and form your opinion on whether the pattern stuff is an impediment or not. Great, thank you. So the meeting is officially ended. I have another small announcement here that is officially now outside the meeting, unfortunately. Most of you will think that signed assertions in this universe are expressed as X509 certificates. So if you go to a random SDO, which one do we take? Fairhair, they will think if they need anything that is signed, this takes on the form of an X509 certificate. And that was probably true for about 30 years. But it no longer is, because we now do have those RFCs that tell us how to do it in a different way. Now, you still may want to use certificates because you have the infrastructure for handling them and so on, but it's important to know there is another way of doing that. And there is a document that has been submitted under the name of this working group. I have no idea whether that's actually a good fit. Let's see, Göran has another document. I should have put that on the slide. Sorry, I didn't think. Can you just say the draft name?
It's called Draft RASA ACE CBOR Certificates.
Thank you. So there are two drafts out there taking different stances on this problem. So the RASA draft is more X509 compatible. This draft is more clean slate oriented. Have a look at those and see whether that might be solving your signed claim problem that you thought you had to solve with X509 certificates.
So this is Henk speaking in concept with Goran, and I think there's a migration path here. So nobody will suddenly jump to CWTs and drop everything that was X509 and AS1. I think that is the part Goran has maybe a few words about, I think.
Exactly. So, I mean, this draft is a profile of X509, but it can still be parsed by the backend. I mean, it can still be generated by the CAs who have the X509 infrastructure in place. So basically, you take an X509 certificate, and you could put the front end, which converts this to CBOR. You transport it in CBOR. Then you have to do in the device the reverse operation to expand it into X509 again, which is a burden. But this is a migration path to have a format which could be natively CBOR eventually. And it also offers the CA infrastructure to be part of that transition path from X509 to other certificates. So that's the proposal.
And the other benefit is that the thing is much smaller than the original X509 certificate.
Definitely, yes, that's the one.
So, and this is Henk again. And the concise identity documents we're talking about here are just a flavor of the possibility how to package assertions, signed assertions in the future. There are other existing drafts that already do use CWTs in the context of asserting something about a device, for example, or something else. And there will be multiple flavors of this, and these can be built on each other. But concise identities, there's an identity document, could be a stage that we arrive at, and therefore Goran's work is like an excellent.
So more about this might be happening in a future interim of this working group. We might talk about this in ACE this afternoon. We might have a revival of the COSI working group, which is mainly going to turn COSI into an internet standard, but which might also look at formats that make use of COSI. So it's not quite clear where this will be done, but there are a lot of people who want this done, and so I'm quite confident that it will be done. And with that, thank you all for sitting here 10 minutes later than longer than you should have. And yeah, see you on the Friday meetings. And tomorrow there are various interesting meetings. And see you in the interims and see you in Prague. No problem. I like it when this works. So